In this lecture, we will discuss a topic related to engineering mathematics 1, and which is beta and gamma function, which is very important topic in the multiple integral of BAS 103 engineering mathematics 1. First, we will discuss gamma function, which is an integration of the form 0 to infinite e raised to minus x, x is power n minus 1 dx, and this integration is said to be gamma function, which is written as gamma n, and this gamma n is 0 to infinite e raised to minus x, x is power n minus 1, where n is any positive number. It may be fraction or it may be integer. So n should be positive for this gamma. And we have some reduction formula for gamma function, which is first one is gamma n plus 1, which one equals to n gamma n. Suppose we have to find gamma of any number, like suppose we have to find gamma of 2, then which can be written as 1 plus 1 gamma, and which will be 1 gamma 1 with the help of this reduction formula. And for this n may be any positive number, and may be integer, and it may be fraction. And for second one, we have gamma n plus 1 equals to n factorial, and this is valid for n as positive integer. If n is positive integer, then this is valid. So for second result, n should be positive integer. For example, suppose we have gamma 2. Gamma 2 means we have gamma 1 plus 1. So according to this formula, this is 1 factorial. 1 factorial means this is 1. Suppose we have to find gamma 5. So gamma 5 means we have gamma 4 plus 1, and gamma 4 plus 1 means we have 4 factorial, which is 24. So gamma 5 is 24. So for any positive integer, gamma n plus 1 is n factorial. And now we have some examples related to this gamma function. We have some integration here, in which we have to evaluate this integration, which is 0 to infinite and 4th root of x e raised to minus root x dx. It means first we have to convert this integration in the form of gamma function. So for this integration, first we have to assume this root x, which in power of exponential function. So first we have to assume this root x as t or any other variable, then x will be t square or dx equals to 2t dt. If we differentiate this one, then we have x equals to t square, which is dx equals to 2t dt. Now after putting these values into integration, we get the integration I, which is 0 to infinite integration, and this is actually 4th root of x, or this is x is power 1 upon 4, and since x is t square, so we have t square whole power 1 upon 4, or we have t raised to 1 upon 2, so which is the term which is t raised to 1 upon 2, and in power we have root x as t, so we have e raised to minus t, and with this one we have dx, which is 2t dt. So after simplification, we get this integration as 2 times 0 to infinite and t raised to 3 by 2 and e raised to minus t dt. And this integration can be written as this is 2 times 0 to infinite t raised to 5 by 2 minus 1 e raised to minus t and dt. And according to gamma function formula, as we know, gamma n is 0 to infinite integration e raised to minus x, x is power n minus 1 dx. So after comparison with this integration, we get this integration equals to gamma 5 by 2, which is gamma 5 by 2. So we have the given integration as 2 times of this integration. So the value of this integration is 2 times gamma 5 by 2. Now we can find the value of gamma 5 by 2 with the help of reduction formula. As we know, gamma n plus 1 is gamma n. So we can write this 5 by 2 gamma 5 by 2 as gamma 3 by 2 plus 1. So this value will be 3 by 2 gamma 3 by 2. So again 3 by 2 can be written as gamma half plus 1. So this integration we have for this gamma, we have half plus 1. This can be written as gamma half plus 1, and which is again we have half gamma half. So this integration will be 2 into 3 by 2 into half into gamma half, and the value of gamma half is root pi. We will discuss later this one. This gamma half is root pi. So we can show this one later. The value of this integration is actually, we have this one will be cancelled here. So 3 upon 2 gamma half. So the value of integration is 3 upon 2 root pi. We will discuss this one later. Now we have another integration which is of the form limit 0 to infinite x is by n minus 1 e raised to minus h square x square. So we have to evaluate this integration with the help of beta function. First we have to convert this integration in terms of beta function, the gamma function, sorry. So we have to convert this integration as integration in terms of gamma function. And as we know, gamma function or gamma n is integration 0 to infinite e raised to minus x is by n minus 1 dx. So first we have to convert this exponential function or this term as x. So we have to make this form as x or t or another variable, but this should be as linear function. So first we have to assume this h square x square as another variable and which is t. So first we have to assume this h square x square equals to t. So we have this one x square equals to t upon h square or x equals to root t upon h. So we get this one. So on differentiation we get dx equals to this one is as we have 1 upon h and this is t raised to half. So on differentiation we get 1 upon h, then half and t raised to minus half, then we have dt. So this is actually x equal to this one. So we have dx equal to this one. So dx equals to this one is dt upon 2h, then we have root t. So on putting these values in the given integration, we get the integration equals to this one I equals to we have 0 to infinite and x is by n minus 1. It means root t upon h whole power n minus 1. Then we have e raised to minus, this one is actually t. So e raised to minus t. Then we have dx is dt upon 2h root t. So on simplification, we get the value. This is actually 1 upon this is 1 upon h, then whole power n minus 1, then 1 power is there. So we get 1 upon h raised by n. Then we have integration 0 to infinite, because the limits are same here. If we have x is 0, then t is 0. If x is infinite, then t is also infinite. So limits will be same here. So limits are 0 to infinite. Now the value of this power of t, which is t raised by half, then whole power n minus 1. So we get t raised by n minus 1 upon 2. Then it is a minus t, and this is 1 upon root t. So on simplification, we get this one as equals to 1 upon 2 raised by 1 upon 2 h raised by n 0 to infinite, and this is power of t. Power of t means this is actually these powers. This is n by 2 minus 1 and the half power is there. So we have minus half. So we have n by 2 minus 1. So this term is actually n by 2 minus 1, which is power of t here. Now this term is actually, or this term is integration 0 to infinite and t raised by n by 2 minus 1, then we have it is a minus t and dt. So on comparison with this integration, we are seeing here that this term is actually n by 2, or this power is n by 2 minus 1. So this whole integration is gamma n by 2. So the value of given integration will be 1 upon 2 into h raised by n, then gamma n by 2. So this is the value of the given integration in terms of gamma function. Now we have some transformations of gamma function here, and very important transformation is here, which is it is a minus k by y raised by n minus 1 dy and equals to gamma n upon k raised by n. And as we know, there is only one formula we have discussed here, and that is gamma n, and which is 0 to infinite integration x is by n minus 1 e raised by minus x. So we have to convert this integration in this form. So first we have to assume this power, since we are seeing here there is power x and there is power ky. So first we have to assume this x as ky. So let this x equals to ky, or dx will be k dy. So the given integration is this integration actually. This integration will be gamma n equals to 0 to infinite integration, then x is ky here, and e raised to minus ky, and dx is actually kty, and limits are same here. If since we have x equals to ky, so if x is 0, then y is also 0. If x is infinite, then y is also infinite. So limits will be 0 to infinite here. So on simplification, we get since this term is k raised by n minus 1, and there is one more k here, so power will be k raised by n, and we have integration limit 0 to infinite a to minus ky and y raised by n minus 1 dy. So the given integration of this gamma function can be written as this form, or we have integration 0 to infinite e raised to minus ky y raised by n minus 1 dy will be gamma n upon k raised by n. So this is a transformation of gamma function in which power is actually ky minus ky, or exponential power is minus ky. Now we have a very important function which is a beta function. This integration is actually limit 0 to 1 here. So integration 0 to 1, x is by L minus 1 and 1 minus x whole power m minus 1 dx, and this integration is said to be beta L m, where L and m are positive here. This is very important formula. Now we have one more decision in this beta function, which is symmetry. So in this formula, if we replace L and m, then the function is same, or beta function is same. So this is said to be the symmetry of beta function, or we can say the beta Lm equals to beta ml. If we see from this one, we have one property of definite integral, and in which we have suppose 0 to a integration fx dx. Then we can write this one as 0 to a and f a minus x dx. So this is the property of some definite integral. So if we apply this property on this integration, then this integration will be 0 to 1, and this is 1 minus x whole power L minus 1 and 1 minus x, then whole power m minus 1, and we have dx. Or we can write this integration as 0 to 1, and this term will be x is by m minus 1 and 1 minus x whole power L minus 1, and we have dx. So this integration will be beta ml. So we can write this one, that beta ml equals to beta lm. So this is symmetry of beta function. So we can change here. We can write beta lm equals to beta ml. So this is symmetry of beta function. Now there is one transformation of beta function in which we have beta lm equals to integration 0 to infinite x is by L minus 1 upon 1 plus x whole power m plus 1 and dx. Now we have a proof of this transformation. As we know, we have discussed this one, that beta lm is this integration which is 0 to 1, x is by L minus 1 and 1 minus x whole power m minus 1 dx. Now if we assume that x equals to 1 upon 1 plus y, then we get dx equals to minus 1 upon 1 plus y square dy, and 1 minus x will be y upon 1 plus y. So after putting these values in this beta function, we get beta lm equals to this x is by L minus 1. So x is 1 upon 1 plus y, which is whole power L minus 1, and this 1 minus x is actually y upon 1 plus y. So we have y upon 1 plus y whole power m minus 1. Then we have dx. Dx is actually minus 1 upon 1 plus y whole square and dy. So these are the values related to this integration. Now we have to discuss the limit. Since we have x equals to 1 upon 1 plus y, so we have 1 plus y equals to 1 upon x, or y will be 1 upon x minus 1. So if we apply lower limit, and that is x equal to 0. So if x is 0, then y will be infinite minus 1, or that is infinite. So lower limit will be infinite. If we apply upper limit, since upper limit is 1 here, so if we apply x equals to 1 here, so we get 1 minus 1, that is y equals to 0. So limits are infinite to 0 here. Now if we simplify this one, since we have minus sign here, So we can adjust this one and we can change the limit which is 0 to infinite. And from power of numerator here, we have y raised power m minus 1 here. So we have y raised power m minus 1. And in denominator, we have 1 plus y here. So power is L minus 1. So we have L minus 1 power and we have m minus 1 power here and 2 powers here. So finally, we get the power L plus m. So this is integration 0 to infinite y raised by m minus 1 upon 1 plus y whole power L plus m. So this is the transformation related to beta function. So we have beta Lm equals to y raised by L minus 1 upon 1 plus y whole power m plus L. And also we can write this one as that is integration 0 to infinite and y raised by m minus 1 upon 1 plus y whole power m plus L and dy. As we know, the beta function is symmetrical in L and m. So we can interchange L and m here. So we have this one here. We can write. So by symmetry of this beta function, we can write beta Lm equals to this one or this one. Now we have very important relation, and that is relation between beta and gamma functions. So this is the relation which is beta m and n. Beta mn equals to gamma L, gamma m, gamma n upon gamma m and n. Now we have to show this relation. As we know, the gamma m or gamma function is actually 0 to infinite e raised to minus t and t raised to m minus 1 dt. This is formula of gamma function. So first we have to assume t as x square. So we assume t as x square, then we get dt equals to 2x dx. Now after putting this value in the integration, we get gamma m equals to we have e raised to minus t, so t is x square here. So we have e raised to minus x square, and this is this term, this one. We have x square whole power m minus 1. Then dt is 2x dx. So finally, we have x is equal to 2m minus 2 and plus 1 here. So we have x is equal to 2m minus 1. Then we have dx and 2 times the integration here. So we have gamma m equals to 2 times 0 to infinite e raised to minus x square and x is equal to 2m minus 1 dx. And similarly, if we have to find gamma n, then this will be 2 times 0 to infinite e raised to minus y square and y raised to 2m minus 1 dy. So these are the values of gamma m and gamma n here. Now here we have to prove this formula, which is relation between beta and gamma functions. So first we have to multiply these equations here. So after multiplication of these values gamma m and gamma n, we get the integration. Since we have definite limits, so we can multiply here. So this is 4 times and limit is 0 to infinite, and these are limits of x and y. Both limits are same, 0 to infinite and 0 to infinite. And after multiplication of these two, we get a so minus x square plus y square. Then we have x is power 2m minus 1 and y is power 2m minus 1. This is actually 2n. So this is 2n minus 1. Then we have dx into dy. Now we have to convert this integration, and this is integration in Cartesian plane, and we can convert this one into polar plane. So if we convert this one into polar plane, as we are seeing here, the region is region in the first quadrant here. This is x axis and this is y axis. So we have region in the first quadrant of, we have complete first quadrant. Since limits are x from 0 to infinite, so we have no limit of x, upper limit of x in right hand side. So we have open interval here. So and same for y. So this is in upper side, there is no limit boundaries. So we have limit of x and y as 0 to infinite. So we have complete first quadrant for this integration. If we convert into polar form, then we have this gamma m and gamma n equals to this integration. So how can find this integration? If we convert this integration into polar form, then as we know that x is equals to r cos theta and y equals to r sine theta. So, we can write this one in place of x, we can write x equals to r cos theta. In place of y, we can write r sine theta. So, this value is r cos theta, this is r sine theta, and this is actually r square. As we know, in polar form, we have x square plus y square equals to r square, or if we square these two and adding, then we get x square plus y square equals to r square. So, this integration is e to minus r square, then we have r cos theta. So, this term will be 4 times and e to minus r square, then we have r cos theta, then whole square, all about 2m minus 1, then we have r sin theta, then 2n minus 1, then we have r dr d theta. So, if we are converting this integration, or we are transforming this integration Cartesian to polar, then first we have to find Jacobian of this one, of Jacobian of xy with respect to r and theta, and we know that this Jacobian is actually r. Now, we have limits. So, limits of r, since we have no boundary for r, so limit of r will be from 0 to infinite, and theta in first quadrant will be from 0 to pi by 2. So, this is transformation of this integration into polar form. Now, we get this integration as 4 times 0 to pi by 2, 0 to infinite e to minus r square, and this integration here, or we can write this one, since power of r is 2m minus 1, 2n minus 1, and there is one more power. So, power of r will be 2m minus 1 plus 2n minus 1 and plus 1. So, finally, we get as 2m minus 1 plus 2n minus 1 and plus 1. So, finally, we have 2m plus n minus 1, which is power of r here, this one. And similarly, we have power of cos and sine here. So, this is the integration in polar form. Now, if we separate these integrations, since we have limits as constant here, so we can separate or as a function of x, r and theta. So, for r function, we have this one, and limit of r is 0 to infinite, and we can write 2 times here and 2 times here. So, and limit of theta will be 0 to pi by 2, and according to gamma function formula, this integration will be gamma m plus n, and this is actually beta mn. So, we can prove this integration with the help of formula of beta function, which we have discussed this one. As we know, beta mn is integration 0 to 1. This integration is beta m n 0 to 1, x is power m minus 1 and 1 minus x whole power n minus 1 dx. So, if we replace x as sine square theta, then we get this integration. So, after putting x equal to sine square theta, we get this value for this integration. So, this is gamma m plus n into beta mn. So, we have beta mn equals to gamma m gamma n upon gamma m plus n. So, this is the relation between beta and gamma function, which is very important relation between these two functions here. Now, very important thing, as I have discussed earlier, that we will discuss the value of gamma half later. So, we have to find the value of gamma half, which is very important. As we know that from a formula in which we have sine is per m theta, cos is per n theta, and this one is gamma m plus 1 upon 2, gamma n plus 1 upon 2, upon 2 times of gamma m plus n plus 2 upon 2. So, we can discuss this formula with the help of this one. We can find this one. If we replace this value with m and this with n, then we get the same value here. Since we have beta mn equals to gamma m and gamma n upon gamma m plus n. So, we can find this with the help of this formula. So, sine is per m theta into cos is per n theta d theta. This integration is gamma m plus 1 upon 2, gamma n plus 1 upon 2, and upon 2 times of gamma m plus n plus 2 upon 2. So, if we put m and n as 0, then the value of integration will be 0 to infinite, sine is 0 theta, cos is 0 theta and d theta. So, we have 0 to infinite integration and d theta. As we have sine is 0 means 1, and this is also 1. In right hand side, we have 0 plus half upon 2, it means gamma half. So, this is gamma half into gamma half upon 2 times of 0 plus 0 into 2 upon plus 2 upon 2. It means finally, we have gamma 1. So, this is gamma half upon 2 times gamma 1 here. So, This gamma 1 is 1 as we have discussed earlier. So, gamma 1 is 1, then this value is half and numerator part is gamma half whole square, and this left hand side is integration 0 to pi by 2 d theta. The value of this integration is pi by 2. So, finally, we have gamma half whole square equals to pi, or gamma half is root pi. This is very important for this function or multiple integral, that gamma half is root pi. Now, we have to evaluate this integration which is integration 0 to 2 x and 8 minus x cube, then whole power 1 upon 3 dx. Now, we can change this integration as integration of beta function, in which we have limits 0 to 1, x is by m minus 1, then 1 minus x whole power n minus 1 dx. So, first we have to convert this integration into integration of beta function. So, first we have to assume that x cube equals to 8 times of y. So, we can see the change here, x cube equals to 8 times of y. So, x will be cube root of 8y, or we have 2 times of y raised to power 1 upon 3, or dx will be 2 upon 3 and y raised to minus 2 upon 3 dy. So, we can put these values here. So, after putting these values, first we have to find this one, x is actually 2 into y raised to power 1 upon 3, and then we have 8 minus this, we have x cube which is 8y whole power 1 upon 3, then we have dx is 2 upon 3, y raised to minus 2 upon 3, then dy. And for limit, if x is 0, then y is also 0. If x is 2, then we have 8 equals to 8y, or y is 1 here. So, this limit is 0 to 1, then we have 2 times here and 2 times. So, we have 4 upon 3, and there is one more 2 here. If we take common 8 from here, then we get 8 raised to 1 upon 3 outside the bracket. So, we get again 2 here. So, 2 into 2 into 2. So, we get 8 upon 3 here. Then limit will be 0 to 1. Then y raised to 1 upon 3 and y raised to minus 2 upon 3, which can be written as y raised to minus 1 upon 3. So, this is y raised to minus 1 upon 3, and this is actually 1 minus y whole power 1 upon 3. So, this is the integration, or we can write this integration as this is 8 upon 3, 0 to 1, and y raised power, this is 2 upon 3 minus 1 and 1 minus y whole power 4 upon 3 minus 1 and dy. So, this is the formula of beta function. As we know, beta function or beta mn equals to 0 to 1, x is power m minus 1, 1 minus x whole power n minus 1 and dx. So, this is beta function. So, we can write this one as beta 2 upon 3 and 4 upon 3. So, this is the value of this integration here. Now, we can find this integration also with the help of these beta function. As we know, beta mn is gamma m gamma n upon gamma n plus n. So, we can write this integration equals to, this value equals to gamma 2 upon 3, gamma 4 upon 3 upon gamma sum of both means 2 upon 3 and 4 upon 3. So, after adding these two, we get gamma 2, and gamma 2 is 1 actually. So, we have 8 upon 3, gamma 2 upon 3, gamma 4 upon 3. So, gamma 4 upon 3 can be written as we know from reduction formula, gamma n plus 1 equals to n gamma n. So, from here, since we have 4 upon 3 gamma, so we can write 1 upon 3 plus 1 gamma, which is gamma 4 upon 3. So, we can write 1 upon 3 and gamma 1 upon 3. So, this term, this 4 upon 3 can be written as 1 upon 3 gamma 1 upon 3. So, after simplification, we get 8 upon 3 into 1 upon 3, which is 8 upon 9. Then we had 2 upon 3 into 1 upon 3 gamma here. Now, there is one more formula used here, and which is gamma n, gamma 1 minus n, and which is pi upon sine n pi. So, there is use of this formula, and should be positive here. So, if we put n as 1 upon 3 here, so if n is 1 upon 3, then we have gamma 1 upon 3, then gamma 2 upon 3, and equals to pi upon sine pi by 3. So, this is gamma 1 upon 3, gamma 2 upon 3 equals to pi upon sine 3 pi. So, this value is, this product is pi upon sine pi by 3. So, this is, since we have pi, sine pi upon 3 means sine 60, and which is root 3 upon 2. So, this value will be 16 pi upon 9 root 3 after simplification. So, this is the use of these formulas here. Now, we have one more integration here in which we have to evaluate the integration 0 to 1 dx upon 1 plus x power 4. So, here if we assume x square equals to tan theta, then x will be root tan theta. So, x will be root tan theta. On differentiation, we get dx equals to 1 upon 2 root tan theta. Then differentiation of tan theta is sec square theta. So, this dx will be 1 upon 2 root tan theta, sec square theta and d theta. So, after putting these values in the given integration, we get I equals to this integration, we will discuss limit of this one. So, this is 1 plus, this is actually x is square then square. So, this is x square then square. Since x is tan theta, so we have tan theta whole square. This term is 1 plus tan square theta. Now, as we know, tan square theta is sec square theta. So, this is 1 upon sec theta and this dx is 1 upon 2 root tan theta, sec square theta and d theta. So, after simplification, we get this integration as 0 to pi by 4 and 1 upon root sin theta and cos theta. So, we can multiply divide with 2 here. So, we get this term as 2 sin theta cos theta, which is sin 2 theta square root of this one. So, we get this integration, and if we assume 2 theta as some other variable t, then d theta will be dt upon 2. So, we get this integration here, and which is limit 0 to pi by 2 sin raised to minus half and t and dt. Or we can write this integration as 0 to pi by 2 sin raised to minus half t and cos raised to 0 t dt. So, we have m and n as 0, as we have discussed earlier. The formula for integration 0 to pi by 2 sin raised to m theta, cos raised to n theta, d theta, and equals to gamma m plus 1 upon 2, gamma n plus 1 upon 2 and 2 times of gamma m plus n plus 1 upon plus 2 upon 2. So, with the help of this formula, we get m is minus half. So, minus half plus 1 upon 2 means half upon 2, which is 1 upon 4. Then we have this term as 0. So, 0 plus 1 upon 2 is half. And then again, we have 2 times of gamma minus half plus 0 plus 2, and which is 3 by 2 upon 2 will be 3 upon 4. So, we can solve this one. This is in numerator we have gamma 1 upon 4 and gamma 1 upon 2, then 2 times of gamma 3 by 2. Or we can simplify this one again with the help of formula. This is gamma 1 upon 4 whole square, and this is gamma 1 upon 4 gamma 3 by 4. So, we can discuss this one as we have discussed earlier. The gamma and gamma 1 minus n equals to pi upon sin n pi. So, if n is pi by 4, 1 upon 4, so we have 1 upon 4 gamma, gamma 3 by 4 and equals to pi upon sin pi by 4. So, which is this one. So, we can simplify this one. So, this is the required value, and since we can't find the value of gamma 1 upon 4, so we can write this gamma 1 upon 4 as it is. So, these are few examples related to beta function and gamma. Thank you.